Hello, my dear young scientists. I am Charu Mani, and today we are going to weave in some magic. So, welcome to the magical world of science. You have studied something in class 7, and that's what we are going to use today. Let's do some magic. So, some abracadabra, and what do you think is going to happen? Yes, the yellow has changed to red, isn't it? And then when I do another abracadabra, what happens now? Can you think what's going to happen? Yes. Now it is again yellow. The red has changed back to yellow. And here we can see some specks of red. Not very good, but yes, we can see some specks of red or pink we can say. So what is it that we remember from our class 7th? And can you tell me what chapter we are going to study today? Yes, some of you have guessed it right. It's acids, bases and salts. So my dear young scientists, today we are going to study about indicators for acid, bases and salts. And now my dear young scientists, I need your help for one more thing. Yesterday we had a party at my home and my son ate too much of sweets and fried foods. And after some time, he started complaining of stomachache. Can you suggest some home remedy for him? I think you all have started thinking, and what you would be doing? You must have first of all thought of the problem statement that my son is having a stomachache due to overeating. Then you must have correlated this to your knowledge of digestive system, that the food to be digested in the stomach needs some acid. So, acid is produced in the stomach. So, you must have noticed that my son is facing the problem of acidity. And then to suggest a home remedy, I am sure you must have suggested baking soda that is available in every household. So, you know now why I call you young scientist? Because that is what the work of a scientist is. They collect the data, they correlate and then they come to a conclusion. So, my dear young scientists, in today's chapter, that is acid, bases and salts, we will have ample opportunities to put on our thinking caps and perform. So, before we move forward, let's recall what we already know about acids and bases from our class 7. So, we studied about the taste, acids taste, sour, yes, and bases, what is the taste of the base? The base tastes bitter. And I would like to tell you that we should never taste anything that is unknown to us. That is the first rule of being a scientist. Unless you know something, please do not put it in your mouth. Okay. So, first property we studied about acid and base was sour and bitter. The next was color change with turmeric. So, turmeric extract, my dear friends, you can make very easily at home. Just boil some turmeric into water and make this extract. I have made it at home. Fine. So, what is there with the turmeric? We just saw it that with turmeric, the soaps or the bases turn turmeric solution to red and acids, they do not change. So, it changes to yellow back. Then we also studied about China rose extract. The China rose extract can be prepared very easily. This is the hibiscus rosa that you have studied in your bio classes. You can just crush it with mortar or pestle, or you can even boil it in water. So, this one that you see it here that I have brought has been prepared by boiling in water. So, with China rose, what we know that acids turn China rose extract to light pink and bases turn it to light green. And the last that we studied in class 7 about acids and bases was the color change with litmus. So, acids turn blue litmus to red. And what would be the color change of acids with red litmus? No color change, red will remain red. And base turn red litmus to blue. So, there would be no color change if a base is put in a blue litmus solution. So this was what we studied in class 7. Now in class 10, we need to know some more indicators, and these indicators are methyl orange and phenolphthalein. These are the new indicators that we would be studying about today. Okay, let's see how these act on acids and bases. So let's get started and see how these new indicators act with acids and bases. So let's start with this colorless indicator, the phenolphthalein, and put a 1 drop of phenolphthalein in first solution, second solution and third solution. So the color change we see from sodium hydroxide solution with this phenolphthalein is a beautiful magentaish pink color, isn't it? So beautiful, bright and nice. But there was no change with acid, and this is my control. We should always use a control while doing some testing, because we have to see what is the color change with water also, because we know water is neutral. Okay. So with phenolphthalein, my dear friends, please make a note, acids do not give any color change, water it was not expected to do, and the base, that is sodium hydroxide, has changed it to pink. Now let us try with this new indicator, that is methyl orange. So a drop of methyl orange here, a drop of methyl orange here, and a drop of methyl orange here. So let's see. With acids, because this set is acids for me, for acids we can see the color has changed to we can say pinkish red, and for water the color has remained the same, because in water we have added, obviously the dilution would be there. And what about base? Is there any change? The base also there is no color change. Okay. So the yellow or the orange remains orange with methyl orange, and the acids change it to red. So can you make a chart? And now I would urge that from home collect few things, material. You can collect lemon juice, curd water and baking soda solution, etc., whatever you find, and make solutions and try testing with the indicators that you have around you. So my dear little scientists, in class 10th, you must be going to the labs to do experiments. But in case you don't have the apparatus, that doesn't mean that your experimentation should stop. You can use any discarded transparent bottles to act as test tubes, and a dropper from a medicine bottle to be used as a dropper. So my young scientists, we have discussed about the indicators of taste, indicators which used our sense of sight, and now I am going to introduce another set of indicators which use our sense of smell, and these are known as olfactory indicators. So this here you can use an onion, you can cut the onion and see how the smell of onion changes when we put some acid or a base. You cannot smell it right now on the camera, but when you do it at home, you will be able to see. The other one is the vanilla extract, the vanilla essence that we use in our baking, that is cakes, etc. And the third one is the cloves. So you can crush the clove and have some clove oil and then see how the smell of the clove oil changes when we put a little bit of acid or a base. This is for you to check. So my young scientists, we have studied about the indicators for acids and bases. So indicators are something like when I am going on the road and I just blink the indicator from the left, without asking me you are able to tell whether I am going to turn towards left or right. So these indicators are going to tell me whether the substance in hand is an acid or a base. Now it is the quiz time for you. So my dear young scientists, it is the quiz time now. And the quiz here is, I have 3 test tubes A, B and C. All of these have a colorless solution. maybe water, maybe something, and to tell you the truth, I also do not know which one contains what. And what my teacher has given me is only a red litmus solution or a red litmus paper. Okay? So I have to use this red colored litmus solution or red litmus paper to check which one contains what. Can you help me? Let us see. This is solution number C. I'll take a little bit of this and let us dip the red litmus solution in this. Wow! The color of the red litmus has changed to blue, isn't it? So, my little scientist, we are sure that test tube C contains a base because it changed red litmus to blue. But the problem is about test tube A and B. What is it? So, I can use easily the blue color that I have. Let me check. So, from the test tube B, I am putting it on the litmus paper which has turned blue, and also from test tube A, I am putting it on the litmus paper which has turned blue. So, let us see. So, test tube A, there is no color change, the blue remains blue, that means it is water. And what about test tube B? Yes, the color is changing. It is changing to red, isn't it? It has changed back to red color. That means the test tube B has got an acid. So, our experiment is complete and the quiz is complete. A contains water because it neither had an impact on red litmus nor on blue litmus. B contains acid because it didn't have an impact on the red litmus, but it changed blue back to red. And C contains a base because it converted red to blue. So, my young scientists, we are done with the quiz and I am sure you all have done good. And now there is a home task for you. You have to set up a small lab at home, find out various natural material that you can lay hands on and they are colored, like some colored flower, like beetroot juice or red cabbage or black carrot or jamun. You can collect the juice and see if there is a color change when you add some soap solution, lemon, curd water, baking soda, etc. You have to just check. Maybe sometimes you will get a color change, sometimes you do not, and you keep recording so that you can classify substances as acids and bases. So, that was all for today, and what we have learnt. We know now how to classify substances as acids and bases. We know the three types of indicators, the indicators of taste, indicators of vision and indicators of smell. Okay? So, and we know how to plan and design experiments so that you can use these indicators to classify the substances that you lay hands on as acids or bases. And my dear friends, you have also learnt that how to collate the data, how to put the data in the table, tabulate the data, and then you know that we have to always report the right observation. That is the sign of a true scientist. Never report anything wrong. Okay? And the last but not the least is to keep your surroundings, the table where you work and the environment clean. So, take care, be safe. Thank you.